let's look at today's lecture. So we took a departure from our textbook. So we've been working through this textbook, Think Python, which introduces a lot of kind of core Python programming concepts. We took a departure from it to get into, the NumPy and Pandas packages along with Matplotlib, which is, which is very important for data science. But they're not part of kind of like the core Python thing. They are, they extend Python's ability with, with those packages, and absolutely you need to use them. But yeah, we took a little bit of a detour. Those things aren't covered in our textbook. I guess in this textbook, Think Python, they are covered in the kind of the other textbook I've linked, which is Python Data Science Handbook, I think, which is also a great resource. But coming back, we will look at Think Python, and now we want to talk about object-oriented programming. And how much object-oriented programming stuff will you do as a data scientist per se? You might not do a ton, but so many bits of Python code use object-oriented programming that I think it's important to learn it so that you can read other people's Python code where they have used object-oriented programming. And so I'm going to assign you homework, and you're going to have to do some object-oriented programming stuff. But I wanted to kind of lay down some foundations here. Let me restart my kernel and clear the outputs. And a lot of this, comes, straight from the textbook. But yeah, you will see a lot of kind of classes and things defined in other people's code, and there are certain things that if you're not familiar with the object model in Python, the data structure, a lot of this stuff can seem foreign. So I want to be sure we cover it. Okay, so there are lots of different kind of Python's built-in types. Basically like NumPy and Pandas, those basically have defined new data types within Python. Okay, and so they kind of build off of this object-oriented stuff anyway. But anyway, we are going to define our own new type. Okay, a new class of object, and this is going to just be a very. We'll start off with a very simple class, and it's going to be class point. And so we'll have capital POINT that represents a point in two-dimensional space, x and y. And if we wanted to represent a point in Python, there's several ways we could do this. One is we could just have a variable x and a variable y, and those are just values that exist in kind of our top-level environment. Okay, we could store the coordinates in a list or in a tuple, or we could create a new class, and that's what we're going to do. Okay, and so we're going to create a class of objects that do this. Creating a kind of new class, new type, is more complicated, but it has certain advantages, and so we'll go ahead and do this. All right, the way you define a point, a new class, is you use the keyword class. Right, so class is a reserved keyword. You can't name something in Python class. Right, it's gonna say that's not allowed. Okay, so you use class, and then you give it the name of whatever this new class is that you're gonna do. The convention, it's not required. You're not gonna get an error if you don't do this. But the convention is if you're gonna define a new class, you use a capital letter. You start off with a capital letter. So we're gonna do class point, and then colon. Okay. And here you actually, we haven't defined anything as far as this class goes. What I have done though is I've given what we call a docstring, okay, just kind of a piece of text that explains what this class is about. And so, if you ask for help later on, you can, it'll tell you, you know, this, it'll print out this doc string. Again, it's customary to use triple opening quotes for a doc string to do this. Okay, so all this does. So our class actually has nothing defined about it. The only thing that has is just a piece of text that I've added, the document string. Okay, and that's it. Okay, and that's enough to define a new class. And so we can say, hey, what is this thing? You can say print point, and it comes back and it says it's a new class that exists, you know, at the top level. Okay, the top level of our kind of environment, which is double underscore main, and this is a point. Okay, so its full name, I guess, would be double under main dot point. And when you create a class object, you can think of it as the capital P thing when you call it. Okay, when you call point, you call it kind of like a function. And this is going to create, it's like a factory that creates instances of this kind of thing, right? So it's kind of like, I'm going to define this class called car, and every time I call car parentheses, like the factory creates a car, okay? And it creates a car, and you'll have like a whole bunch of instances, right? And you get to drive a car, and somebody else gets a car, or something like that. It just creates a bunch of these things. So here I'm going to use capital P point parentheses to create an instance of the point, and so this is just a blank one with absolutely nothing, okay? And here it says, oh, okay, this is an instance, and it's located at this position in memory, okay? So it just creates an object, and it says, okay, this object now exists somewhere in your computer's memory, and if we need to use it, like I can reference this address, and we can work with it. And okay, so this is all very like, there's like nothing's happening. We just have like this blank class, but we've created things. Okay, so what we can do to kind of actually make it useful is we can give the class, our object, some attributes. So here I'm going to take the object that exists in memory, which is this blank, it's called blank, and I'm going to just create a new attribute, blank.x. This is an attribute, and I'm going to say we're going to assign the value 3.0 to it. And then I'm going to create a new attribute, blank.y, and we're going to give it the value 4. This is not part of the definition of point. Okay, in point I never defined an x attribute or y attribute, but here you can just take an existing object and you can just throw new attributes in it. Okay, it's a little bit kind of wild and loose there. All right, and you know, you've seen a little bit of stuff for like storing values or variables within a module. You know, you're familiar with like math.py and things like that. Here we're assigning values to, I guess, variables within an object, and so I'm going to do so I can retrieve this, and I can say, hey, what is blank.y? And this is 4.0. All right, that's exactly what I left off, and I can create a new variable outside in like kind of the top level here, and I can say, hey, let's take blank.x. All right, we can retrieve that, right? And that's going to be 3.0. We can assign it to x, and there's no conflict here. These two things are completely unrelated. Blank.x and this x. This is just, we created a new object called x at the top level. This is 3.0. I can change the blank.x. Okay, the attribute inside x. I can change that to say 5. And you know, the value outside is still 3.0. Okay, so this command over here just creates an entirely separate thing. They're not connected or linked in any way, right? this, so if you change what the value inside the object, there's no connection between the x outside and the x inside the object. Okay, we just happen to retrieve the value for blank.x and give it to the variable x on the outside, but there's no actual link there. Okay, so let's say you wanted to kind of look at the values inside. Okay, so if I asked, hey, what is blank right now? Okay, it still says, oh, you got this object, a main.point object located at this location memory, but you want to be like, hey, what are the values of x and y inside here? We can I can create a format string, okay, right? So using curly braces as kind of like placeholders for values. I have two curly braces, which means I can unpack two values here. So I can do blank.x, blank.y, and it'll fill in those values in here, okay? So, x is currently 5 because I changed it here. Y has been 4 and hasn't been changed, so I can take that and throw that in here. And, if you want, you can create a function. So I'm going to create print point, and it's going to take some object p, and we can do this. All right, so here I'm defining a new function called print point. Takes an object p, and I can do print point blank, and we get 5, 4, right? But if I create like a new point is equal to point here, and I say print point new point, this thing I'm going to get an error because new point doesn't have an x, right? So far, new point dot x, doesn't exist. But I can assign it something. Right? I can do new point dot x is that, and new point dot y is this, and now I can do print new point, and print point. Okay, and that will work. Okay. And now that I've run this will work. Okay, but don't actually have to do this. All right, so what if we want to okay, so we're going to make a slightly more complicated object, okay? And this object this class will contain objects of class point in it as well. So we're going to create a class to represent rectangles. How do we represent a rectangle? And there's a couple options. One is we could specify one corner, and then we'll specify the width and the height. So it's like, how do we define like where a rectangle that exists somewhere on some Euclidean plane? Or you could like specify, the top left corner and the lower right corner or something like that, right? So here I'm going to just create a new class called rectangle. And again, right now my classes has no like actual definition. All I'm throwing in there is a docstring, okay? And the docstring says, hey, these are the attributes, width, height, and corner. And so we're going to specify within, so here I create class rectangle, and then I'm going to create an instance of rectangle called box, and I'm going to create attributes. Box.width is 100, box.height is 200, and then we're going to specify a corner, and we'll do box.corner, and that's going to be a point object, and we'll say box.corner.x is 0, and box.corner.y is 0. Okay, so you can imagine just, on the Cartesian coordinate plane, you've got a rectangle where, the corner is at 0, 0, and then it's got a width of 100 and a height of 200. And so this is, a very manual way of doing this, but we can do that, okay? And we could say, all right, if we have a rectangle, let's figure out what the center of this rectangle is. So, let's imagine, our rectangle, its lower left corner is at 0, 0. where is the center of the rectangle? It's got a lower left corner 0, 0. Its width is 100. Its height is 200. So its center is going to be at coordinate 50, 100, right? And so how do we figure that out? Well, we'll take the width divided by 2, the height divided by 2. We'll take the x coordinate and add on the width, and we'll take the y coordinate and add on half the height, and this will be p and x, right? So here I'm going to do find center of the rectangle. We do this, and so this is a function, and we're going to run the function on our rectangle object, which is box. Okay, and right now center. What is center? Center is just a point object where we've assigned some attributes to it, and so if I want to see what's in there, I'd have to call the function print underscore point. Okay, so far everything's been very manual. My class definitions are all blank, just doc strings, nothing useful in there, and we're just kind of assigning attributes as we go along, which Python allows. Okay, it allows you to just kind of create new attributes that weren't necessarily part of the class definition, which is different from other languages and stuff. It gives it some flexibility, but also can lead to trouble at some point too if you're not careful. Here is box width. Right now it has a width of 100, and if you wanted to, you could just modify these things, right? So I'm going to take the current box width and add 50 and assign it back to box width. Okay, I'm going to add 100 to the height, and so now my width is 150, and my height is now, what is my height? My height's now going to be 300, okay? And so here, I could do find, is that the name of the thing? Find center of my box, and then let's print the point. Right, so now I have a new width and a new height, and I can run kind of my new object here. Okay. Here I can have other functions. Here I'm going to create a new function that is going to grow the rectangle. So it takes in the rectangle, and we're going to add width. So this is d width is like delta width, delta height, and we're going to take rectangle width and add the width, rectangle height and add height to it. Okay, and so this is interesting. This function doesn't return anything, right? So a lot of functions that we've written, it returns something. This function is not returning anything, but it does have an effect. It does take our currently existing box, which currently has a width of 150 and a height of 300, and I can add an additional 50 and an additional 100 to this, and because of the way this function is written, it's going to take that rectangle and modify its attribute. Okay, so if I do grow rectangle and whatnot, now my box width is 200 and my box height is 400. So even though this function doesn't like return a new thing, it takes an existing object and it modifies it. Okay, and so your objects that you create in Python are mutable in that they will be modified. Okay, let me give you your first view quiz answer for today, which is the letter A. A is your first view quiz answer for today. A. A as in apple. A as in apple. Okay. Now, one thing that sometimes throws students off is when you write your functions that take, say, an object that exists and you want to alter it, right? So in my function definition, I said we're going to take in an object and we give it the attribute name rectangle or rect, and we're going to do rect.width and rect.height. When I call the function grow rectangle and I pass the object box to it, then within the function, rect becomes an alias, okay, for the object box, right? When this function is being called and running, right? And so within this thing, it's basically going to call box.width, box.height, and modify those things. So sometimes the naming of, I guess, arguments within a function can throw off some students, but so just make sure you understand this, and sometimes as you write your function, it you can get thrown off. So try to keep track of your variable names. That's always like one of the hard things of just programming in general, is like remembering your variable names. It seems so silly, but it's easy to get mixed up along the way as you're just writing all kinds of stuff. Okay, let's keep trying. So anytime you create an object, okay, so you have these kind of mutable objects. So here I'm going to just create a blank point, and again, remember my point has nothing really defined other than the doc string, so nothing of actual value here. We're going to just create some attributes that go with it, and I'm going to import the copy module, which just allows us to kind of copy objects. So I'm going to create copy the point. This is going to be P1 and P2. So P1 is 3, 4, P2 is 3, 4. Is P1 equal to P2? This is this comes back false, and P1 is P2. This is these are false. So even though they have the same data, they are not the same instance of a point, right? So if you say, what is P1 and what is P2? P1 is a point object at this location in memory, and P2 is an object at this location in memory. So they are not the same object. Whereas, whoops, if I do P3 equals P2, all right, so if I say, what is P3? P3 is this. What is P2? Okay, they are the same object in memory, so I could say P3 is P2, and that comes back true, right? So we're saying, P3 and P2 are pointing to the same location in memory. So that's, P3 is basically just an alias for P2 here. Okay, let's, right now we have a box. It has a width and height of 200 and 400, and this box has a corner, and the corner of x is 0, and the corner, corner has an x and y of 0 and 0. And so what we're going to do is we can try making a copy of the box. So the default is that the copy is going to be a shallow copy of the box, okay? So box 2 is a copy of box 1, but they are different instances. So right now, box 2 is also width 200, height 400, with a corner at 0, 0, okay? But it's a different instance. It's like, you have twins, and this is not true. Twins aren't copies of each other, but they're kind of like copies of each other, but they are separate people, right? They are separate people. Okay. If you ask, what is the corner of box 1 and what is the corner of box 2? Okay, those corners are the same. Okay, so what's box 2's corner? It is a point located at this location in memory. What is the corner of box 1? It's the same point, okay? And it's kind of like, what is the parent of this person and what is the parent of their twin? It's the same person. They're not copies. It's not like this parent and this parent, they're like not duplicate, different people. They are the same person, right? So a shallow copy creates a copy of an object, but if that object contains other objects, it only copies the reference. It doesn't actually create a different one. So here, if I take box 1 and I say, you know what, let's move the x, or change the x to 1. Okay, box 1's corner.x is 1. And because box 2's corner is the same object as box's corner, this corner is also going to become 1. Okay? Whereas, you know, the height values are separate. So if I change the box height from 400 down to 200, box height becomes 200 and box 2's height remains 400. Those are separate because they're copies. On the other hand, if you wanted to create a copy of the object and copy any of the objects inside the object, you have to do a deep copy. So I can take box and do a deep copy. Box 3 is going to be a separate instance, and box 3's corner is going to be a separate instance from box's corner. Right? So that's, I think we've seen copies and deep copies before with lists. It also applies to objects that we create. Okay, let's do a little bit more. All right, so here we're going to create a class called time, and we're going to use it to try to represent the time of the day. Okay, and so right now my definition of class is empty, just has a doc string. And we're going to have 3 attributes: hours, minutes, and seconds. Okay, hour, minute, second. Okay, so we're going to say 11:59 and 30 seconds. We're going to create an instance of the time object called lowercase time, and then we're going to print time. And this just is this is a format string. Okay, and this says, you know, take a number and whatever it is, make sure there's 2 digits. So for example, if I only had 3 seconds here, when I print it out, it's going to add leading zeros here, okay? So that's what we have here, okay? So we're going to use the format string, put colon in between, you know, kind of our string fields, and this says, you know, let it have like a leading zeros, and you know, make sure we've got 2 numbers in here. Okay, so we can create, you can think of 2 different types of functions. We have pure functions and we have modifiers, and we've seen both of these. Okay, a pure function takes arguments in, doesn't modify any of those objects, but it takes them in, it, you know, looks at the values in them, and then it does stuff, and then it returns a new object or a new value or whatever it is, okay? So the pure function has no effect on anything other than returning a new value. That's a pure function. Whereas a modifier will take objects and actually modify those objects, okay? You know, as you write functions and develop stuff, one of the ideas is this plan called prototype and patch, and this is covered in your textbook. And prototype and patch is a decent strategy where you start off with kind of like a very bare bones implementation of your thing, and then once you get that working, you add to it, you patch it, you add to it, and you kind of build up from there, right? So it's kind of like this start and then grow. And then, you know, there's other kind of top down, you know, you start off with an idea from the start, and then you work down. So here we're going to say, what if I wanted to take 2 time objects and add them together? So here we're going to create a function called add time. This is going to be a pure function. It's going to take time t1 and time t2, and it's going to add those 2 together and return the resulting time. So we're going to start off, and we're going to create a new instance of time called the sum, and we're going to take t1's hour and t2's hour, add them together to get the new hour for sum, t1's minute, t2's minute, add those 2 together to get the sum of the minute, and t1 second and t2 seconds to add those together to get the sum of the second. Okay, so here we'll try this. We'll say start time is 9:45. Duration is 1 hour and 35 minutes and 0 seconds. And so if you started something at 9:45 and it took an hour and 35 minutes, when do you finish? We would finish at like 11:20. Okay, so let's try this add time thing. And what does it return? Well, it did exactly what we asked it to do, which is says it take the 9, take the add 1, add them together and it gets a 10. Take the 45, add the 35 and it gets 80. And that's the minute, and take the 0, 0 for the second. So we get 10 and 80. And this, this isn't quite right? So, what do we do? Well, we can try patching this, all right? And we can say, okay, if any of these things ends up bigger than 60, subtract 60 and add 1 to the minute. So if the number of seconds is greater than or equal to 60, subtract 60 from the seconds, add 1 to the minutes. If the number of minutes is over 60, subtract 60 from the minutes and add 1 to the hours. So let's try this out. And if I do start 9:45 plus hour 35, we get 11:20. That seems correct. Okay. So far, okay. Let's write a different function. So this was a pure function in that if I say, hey, what is start? Start is still print time on start. Start is still 9:45. Print time on duration is still 1:35. These things didn't do anything. This function of add time doesn't modify either of the objects that we gave it. Whereas here we can create a function that we're going to call a modifier, and it takes the object itself as one of the parameters, and this function modifies the object. So here we will create a function called increment, and it takes a time object. It also asks for the number of seconds to increment by, and what we're going to do is we're going to add the number of seconds to the number of seconds, and if it's greater than 60, we'll subtract off 60 and add 1 to the minute, and if the number of minutes is greater than 60, we'll subtract off 60 and add 1 to the hour. So here we will try this out. We start off with our test time at 9:45, and I will increment test time by 90 seconds, and that seemed to work. Okay, we added 90 seconds and we end up at 9:46 and 30. And let's try incrementing it 185 seconds. And now, now it breaks. Okay, so incremented a minute and added 125 to the 30. So we say, oh, you know what, this is no good. Okay, so it carries once. Like it looks at if it's greater than 60, it subtracts off 60, and it increments it by 1. But if you're incrementing it by say 3 minutes, this is not going to work, right? And I mean, you could like run a while loop or something, but probably a more efficient method is to do modular division, right? So we have div mod, which will tell you like how many times it fits in and the remainder. So I'm going to take the number of seconds and we'll div mod the seconds, and we'll get the number of minutes and the number of seconds. And then if the number of minutes that we have is over 60, we can div mod that 60, and we'll get the number of hours and the number of minutes. So this will be increment will have time.second, time.minute, and time.hour. So we'll take, so we div mod the seconds and we increment any of these things. And then if after doing all of this, okay, so now we know none of the seconds or minutes are going to be greater than 60, we can kind of, we can then do this, right? We'll still have to kind of check if the sum ends up over 60. So here I start off with at 9:45. I could say, all right, let's add 185. And so again, this is a modifier. It takes our test time and it modifies it by adding 185 to it. And that looks correct. Okay, we could say, let's add 4,800 seconds. 4,800 is 1 hour and 20 minutes. And that also seems correct. Now we end up at 11:08:05 or something like that, right? If you can do it with a modifier, it can also be done with a pure function. Modifiers are convenient and great, but they can become difficult to debug in that if you're not careful, again, if the way you write which objects get modified, like for example, if like within your function, let's say you make a reference to some object called start or duration or whatever it is, and you modify that, you might be changing values of objects in the main environment, and it might not be obvious that those objects are being changed, right? If you make a mistake during your coding, and that's inevitable, people make mistakes, okay? And if you if you reference an object that's not coming in as an argument, it's going to search for that object in the main environment, right? And then it's going to start modifying those things. And then, and you might be wondering, like, when did this value change? How did this value change? And it's not going to be obvious or clear where that change happened. So it can make it difficult to debug. I mean, the flippant answer is, well, just don't do that, right? Be careful when you code. But it is, it's easy to make mistakes, and so just sometimes as you're like trying to debug, you have to be like, okay, what is the value of the environment here before I run the function, and then after I run the function, what is the value of the variables in my environment, and is everything what I expect it to be, or are things changing in ways that I'm not expecting? The alternative to this prototype and patch idea of development is you can have kind of this planned or designed development, okay? For prototype and patch, we wrote a prototype that performed the basic calculation, and we tested it, kind of fixing things or patching errors along the way. And this can be effective, especially if you're not quite sure and you just kind of have a loose idea of how it goes. But this is true. Incremental corrections can generate code that becomes unnecessarily complicated. And oftentimes you start off with something simple and you say, okay, we need to make an exception for this, and an exception for this, and an exception for this. Okay. An alternative is if you start at the beginning and you already know exactly what needs to happen and how it's supposed to work, then you can take this designed development approach. And so one way to deal with time and say, you know what, let's add these things together, is we could take time, and rather than think of it as hours, minutes, and seconds, just say, hey, let's represent our time as the number of seconds since midnight, okay? And so if it's like midnight, it would be 0, and if it's 12:01 a.m., it would be 60, and if it's 12:02, it would be 120, and if it's 1 in the morning, then it would be 33,600, and so on and so forth. And so, one function that we'll do is we'll take our current, our time, we'll take the number, we'll get the number of minutes by taking the hour, multiplying by 60 and adding the number of minutes, and then we'll get the number of seconds by taking the number of minutes, multiplying it by 60 and adding the number of seconds. So this will return the number of seconds. And then we need kind of a counter function, the reverse function, that will take the number of seconds and convert it back to time. So here, for this, we create a function called integer to time, creates a new instance of time. It's going to div mod the number of seconds into minutes and seconds, and it's going to div mod the number of minutes into hours and minutes. Okay, so we'll just test this out. Our test time will be 9:45 in the morning, and we print out 9:45. Let's turn it into the number of integers, or number of seconds. It says 35,100. Okay, that sounds reasonable. I don't know. All right, and then let's convert it. Let's try 35,100. Put that into the function integer to time, and print that out. And indeed, we get back 9:45, right? And you can try, you know, values that you do know, like 100 seconds after midnight would be like 12:01 and 40 seconds. Okay, so we get 01:40. That sounds right. Okay, so that looks good. Okay, so now that we have turned everything into integers, then now adding the time, our function becomes way simpler. All we have to do is we take time 1, turn it into a number of seconds, take time 2, turn it into a number of seconds. We can just add those two numbers together, and then now that we have a new sum, we can return a time by using integer to time. Okay, so that's it, right? So now I can do I think print time start is still 9:45 and print time duration is still 1:35. So I can now do, say, add time, start comma duration. I gotta print time that thing. All right, and now it prints out 11:20. So this add time is just way simpler than whatever we had back here, right? So, you know, we converted everything into the number of seconds since midnight, and that's just an easier way to kind of deal with it. And that's, you know, the calendar on your computer kind of works that way as well, right? It's just the number of days since January 1, 1970, and that's what we have. Okay, I'll go ahead and give you your last two view quiz answers, and they are the letters C as in cat and E as in elephant. C as in cat, E as in elephant are your last two view quiz answers. C as in cat, C and E. All right, I'm going to keep going. We're going to run out of time to cover this whole notebook, so we will pick up and try to finish this on Friday. This is just kind of a longer notebook covering stuff. So far, all of our classes have just been empty. But what we can do is we can start defining methods, and methods are going to be functions that are associated with a particular class. So methods are basically the same as functions, but the key difference is that the method is defined inside the class, and then when you want to call a method, the syntax you use to invoke or call the function is different. Okay, so this is kind of what we have here. We have, so far we've just defined a blank classes, and then we've defined functions outside of that, right? And then the way we would call this is I defined attributes within this thing. So at my start, I've defined kind of these attributes: hour, minute, second. And then I have print time, which takes that function and runs with it. Okay, so here when I define a class, and I've been using docstrings just because if I did this without the docstring, I would get an error, right? It's saying like you need to have something, and so just to kind of avoid the error, I've been just putting in a docstring. But now I'm going to define a class, and I can still include the docstring, but here within the class, I'm going to define a method. And this method is going to just I'm going to run this, write a function print time. So basically this exact same function, define print time, is going to be defined inside the class. So all I've done is just copy this code and just paste it inside the definition of class time, and it's indented, right? So when it's indented, now we know it belongs to the class, and that's this. Okay, so now I have to create a new instance of this. Okay, so this object start was created under this class definition of time, and now that I've redefined the class definition of time, I have to recreate a new object of start here. Okay, so here I do this, and so here is start, and that's that. And now to call the method, well, okay, you can do this. You can do the class definition and call the method and put the object in it. That's, I don't think anybody really does that, okay? Generally, you just we've defined this object start, and you call the method from inside of it. And when it does that, it's gonna basically call it on itself here, okay? And it says, oh yeah. So when you call a method from the object itself, the object is going to become basically the subject of the method, and the subject gets passed to the method as the first argument, and so it's going to get passed into this thing for print time. Okay, so inside print time it says time, and so even though I didn't pass any kind of argument in here, when you call start.printtime, the definition knows to just kind of pass itself as this argument here. Okay. Now the convention is whenever you pass the object's value itself in there, the name you use is going to be self. Okay, so a lot of times as you're reading someone's Python code, you will see reference to self all the time, and that's just anytime you invoke a method, okay, the object gets passed in as its first argument, and that's going to be self. So anytime you see kind of these methods written inside a thing, you're going to see self. And so this is basically the exact same thing that I've written up here, except following the Python naming conventions, we're going to use the word self rather than time. Okay, so we're going to do print time self, and then self.hour, self.minute, self.second, and that's all we've done here. Okay, all right, we're gonna we'll end here. We'll pick up and continue talking about object-oriented programming on Friday, but this is a good spot where we're starting to kind of define our methods for objects here. Okay, I think I gave you all 3 view quiz answers, so that will be that. Have a great rest of your day. We'll see you on Friday.